The concept of ionization of water explained by James Sito, Alvin Tran, Maggie Nguyen, and Alex Ma.
Water is a substance that is able to carry out a reduction reaction as well as an oxidation reaction, and these reactions together produce ions in the water. We can use an analogy to explain what happens to the water when a voltage is put through it. There are two guys, positive Peter and negative Ned, who live next to the sea. They don't usually fish, but the fishing market is going crazy and they want to join in the action. Positive Peter decides to buy a crab net and goes out to catch crab, and negative Ned buys a fishing rod to fish for trout. The weird thing about the crab living in this sea is that they really like to grab trouts by the tail with their strong pincers. Positive Peter sets out to catch some crab and manages to catch a few. The crabs he caught were holding onto some trout. But according to the law in the town, a fisherman is only allowed to catch one type of seafood at a time. So, he returns the trout to the sea and gathers the crabs in bags of 2 to sell. Meanwhile, negative Ned is out fishing for trout. When his hook catches a trout, he tugs hard and the crab attached to it loses grip and falls back into the water. Ned is happy with his catches and sells the trout in bundles of 2. The crabs then search for a new trout to grab onto once again. On days when demand for seafood is higher and business is growing, Peter and Ned fish more and more to earn that nice cash. However, when demand for seafood drops, Peter and Ned fish less or may even look to find a new job. Here we have the experiment set up. The negative electrode or cathode is Ned, and the anode is Peter. The voltage can be thought of as the strength of the fishing market. If there is enough voltage, the ionization reaction will start to happen. The oxygen are the crabs, and the hydrogen are the trout.
Now that you have heard the story of negative Ned and positive Peter, let's head over to the lab to learn about how temperature affects the ionization of water. The ionization of water equation is 2H2O liquid plus heat equals H3O plus aqueous plus OH minus aqueous. Since the heat term is on the left side, the reaction will be endothermic. Because the ionization of water is in equilibrium, whenever we affect the temperature, the equilibrium will shift according to Le Chatelier's principle, causing the amount of ions present in the water to be affected. Therefore, the conductivity of the water is also affected. In our first scenario, we will be tackling an increase in temperature. In this case, the increase in temperature will cause the conductivity of water to increase too. As we dive deeper into detail, we will see that when the temperature is increased according to Le Chatelier's principle, the equilibrium will shift to the right to counteract the change. This will cause the concentration of H3O plus and OH minus to increase. More ions will become present in the water, causing the conductivity of water to increase. In our second scenario, we will be addressing the decrease in temperature. In this case, the decrease in temperature will cause the conductivity of water to decrease. As we dive into the details again, we will see that when the temperature is decreased, according to Le Chatelier's principle, the equilibrium will shift to the left to counteract the change. This will cause the concentration of H3O plus and OH minus to decrease. Fewer ions will become present in the water, causing the conductivity of water to decrease. On behalf of Negative Ned, I would like to thank you for watching our cartoon. Now it's time to go over to watch the Chembusters.
Created using Powtoon.